Cool. Well, let's start. Uh, Yesterday I left on day 10, part 2. So we'll probably work a little bit on that problem and see where this goes. Give me a minute. Cool. Hope I'm audible and my screen is visible. Okay, let's get started. So yesterday we figured out that there could be different number of variables associated with the operations that we need to apply, and let's formulate this. Cool. So let's say we have an operations, and each operation can be performed, let's say xi number of times. That yields us a variable something like this. So let's say the first operation has some indices to be incremented. Then it could be either 0 or 1. So let's take an example that this operation, when applied x one number of times, it will increment the target array's 0th indexed by some amount, which is the number of times we are going to apply it. So 1 times x1 plus 0 times x2 plus so on, and xn, and this is the first index of the target array. So this should be t0, or let's say for one best indexing, this is t1. The same thing will continue for all other variables. So this binary number 0 1 is the only variable here. It's something like this, and this can be represented in a form of a matrix. So let's say all the operations are transformed from a representation like 0 2 3 4 to a binary row of a matrix, which looks like this. So 0 index is set, 1 is not set, 2 is set, 3 and 4. So this is how all the operations would be transformed into, and after this transformation we need to make sure that this condition holds. And to do this, so all the operations will be creating a matrix. Let's say this is an example case. So this is the entire matrix. So let me replicate this. So for example, this is the matrix, and there would be x1, x2 and so on, xn. These are the variables of number of times an operation needs to be performed. So this is how we will arrive at a equation that we need to satisfy, and this should ideally match to the target array. So this should be t1, t2 and tn. So this is the condition that we need to fulfill. So I took a little bit of help from ChatGPT just to solve this constraint, and not specifically asking the solution to this problem. So I'll probably go through this right now. To solve the equation x equals to b for vector x, while trying to minimize the sum of elements of it, we need to clarify the nature of the system. If A is a square non-singular matrix, there is only one solution for x. Minimizing is impossible because x is fixed. However, if A is a wide matrix, more variables than equation, there are infinitely many solutions, and we can use linear programming to find the one that minimizes the sum. The setup is like this. Let me also check what is the size of that. So we saw that we have around, this is the target array, and the target array size is at most like what do we say, it's I think 10, it's max 10. Let me check it again. This is the target array. This should be the number of rows in the, or number of rows in the target array. So this is like 2 3 6 7 9 10. So let's assume it is 10 because we have also verified that there are only single digit numbers in this operations list. So this goes from 0 to 9, and there would be 10 numbers in this. And after that, so if there are 10 numbers, can we assume that this is a square matrix? Not necessarily, because the number of rows, or this particular n here, is the number of the operations that are given to us. So this is variable. So in this case we were given 6 rows, in this case we were given 5 rows, in this case we were given 4 rows. So definitely this is not a square matrix. See, we need to minimize f of x, which is the sum of the variables subject to this, and all the variables are positive, non-negative. Solving the linear programming, the simplex method, since a and b contain positive numbers, you want to minimize the sum. This is a classic constraint optimization problem. Define the objective function. Write the sum as a dot product where c is the vector of ones. Set constraint if your variables must be non-negative, which is common when dealing with positive numbers in the constraint. Add this condition. Use a solver. In Python, use SciPy optimized linear programming. I mean, we can use this, no doubt. But I want to understand a little bit about how these equations are solved, because I tried to look into Gaussian elimination for this. So we are solving linear system of linear equations. So this is like Gaussian elimination. But I went through this article, but I don't think they have any specific solution to minimize the sum of the variables. That's why I had to use ChatGPT just to understand if there is any standard approach for this. The function uses 2 pointer for each variable xi. The value verifies the line where the column is not 0. The vector is needed because some variables can be independent. In this implementation, the current ith line is not divided as described also in the n matrix. It's not identity matrix. The dividing the ith line can help reducing errors. Let's go through some other articles as well. Okay, we don't want this. Linear defined 10 equation, we also don't want this. I think this is a 2 variable equation, so this is not required. Linear congruence is also not relevant. Solve system of linear equations, minimize sum of variables. To solve a system of linear equations while minimizing the sum of variables, you treat it as a linear programming problem. Define your equations as constraints or a equality boundary. Express the sum as objective function to minimize, and use methods like graphing or the simplex algorithm to find the solution point within the feasible region that yields the lowest sum. Okay. I think I'll try this first. Coefficients for the sum. And I would assume that there is always a solution to this. Because we need to add something into the answer, and the fewest button presses required to correctly configure the voltage level counters on all of the machines. So this should always be possible for a given set of values. I doubt this has a simple greedy approach. Maybe I'm trying to overcomplicate this. Let's see how this goes. Two equation, three variable. What is this technique called? Where are we? Checking for non-negative values of the required variables. This technique is called linear programming. Specifically, when you are minimizing the sum of variables subject to equality, it is often referred to as the standard form of linear program. Non-negative values, the condition that variables cannot be negative, is called the non-negativity constraint. It is checked or enforced in two main ways depending on how you solve the problem. In mathematical formulation, you explicitly state xi is greater than or equals to 0. This is a logical check because in most real world scenarios like quantities or products or amounts of money, negative values are impossible. Give me the corresponding Python implementation to solve this. Okay, so let's say we have these variables 1 2 1 and so on, and p is like this. So this is the target array, this is target array, and these are the coefficients array. Cool, let's try this. So we were at date 10. Let's use main.py. Paste this. And I just need to give this input. Let's read the input from lines. We have the smaller input here. So open in read mode. Read lines. Does this have a strip method? Read dot strip. So this will remove the extra new lines from the end. Split on new lines, and let's go over the lines. Sprint line. Python 3 main.py. This should be in. No module numpy. So let's init a project here. Let's do uv run main.py. We don't have scipy, so uv. How do we install scipy through uv? Uv install scipy. Uv init. I think addition should be fine. Let's do this. Init add scipy. Uv run main.py. Oh, this was already too small, too slow to run. I'm not sure if this will be able to solve it, but let's see. I mean, at least I want to get the answer for the sample case. If that is achievable, then I'm fine with this problem. I'll probably go on to the next one. Cool. Now we have the lines. For each line, I need to get the parts. Line dot split on space, and the operations would be filter part for part in parts. No, let's do it like this. It should be a list, and if part dot starts with or part of 0 is opening bracket, and this is closing bracket, which should be the target. Let's try printing this. Cool. We got the array of strings. So I'll probably split it here only. I want to get part dot let's do 1 minus 1 Python remove first and last character from string. Yeah, 1 minus 1 should be good. let's check once again. Cool. Now I need to extract out the numbers from this. So this should be list of this portion split over comma, and let's do one thing. Let's write a helper function for this. Left create row. This text in nums, and this has a list of size 10. There should be row is 0 for underscore in range 10. This should return row, and for num in nums we should set that particular index should be int of num equals to 1. Cool. So list of strings is also fine for this. So split on comma, and then I need to create row over this. Let's try this once again. Cool. So we got 0, 1, 2, 3. 3 as the first, which is this one. Then 1 and 3. 1 and 3. It looks good. Let's move on to the target part. This I think should be 1 minus 1 split on a comma, convert it to list, and create. We don't need it to create a row for this actually. So if we create this, what else did we have here? We had a string of this. We need to convert this into a list of integers. Should be not split on comma, and map them to integer first and then to a list. They should be split. Cool. So we got numbers here. Let's remove this. So this is also not required. So now instead of these lists here, I need to send in ops, and I mean ops is already a matrix already, so I need to send only this thing. Let's copy this just for backup. This should be ops, and this should be target. Let's run this. Float argument must be a string or a real number, not a map. Where is this failing? So I've printed this. This is a list of map. Let's convert this into list like this, maybe. Still it's not correct. Let's do it like this, x for x in this, What else did I change here? I don't think I changed anything. Why is this a map of list? This is still a map. Let me do one thing. I'll do this manually. So let's say we have this part. We remove this. Where was I? Remove this. Then this should also fail, but I need to convert this into a list one by one. Or so now this must be a list of strings, and I need to convert them once again. I'll probably use like this. We don't need to get the list again. So once this creates numbers, what's the issue here? Let's traverse the numbers. I mean, this would also be fine, ideally. I'll add those numbers one by one. What's the issue here? Let's make target as target is an array, and this gets assigned. The target is X, and target is let me do this simply in a basic format. So this was nums. Let's say this is T. This is T. I need to get target is T0, or let's say T is T0 and target is int x or x in T. Maybe this solves it. And this looks correct. 3547. Invalid input for linear program. B equals must be 1D array. B equals must not have more than one non-single dimension, and the number of rows in A equal must be equal to number of values in B equals. So why do we have so many number of rows? So we have 5 rows and this is 4. 1, 2, 3, 5, 6. Let's test this a little bit. So we have 6 steps here. So the matrix would look something like this. We have a 6 by 10, 6 rows and 10 columns. This is multiplied by a matrix which has all the variables. So this has like 10 variables, 1 column, and the target is target should have 6 values, but I don't think that's the case. So this should be 6 by 1 ideally. So the max element in this step should be the size of the target array. I think that is how it should be configured. So this one will give me 4 as the max value. So let's see, this is columns as, wait, we received this one. I need to extract out what is the columns in that. Let's rename this as create A. This should be we should pass in the list entirely to this. Okay, so if this is the matrix, the column should be the maximum element. So let's traverse the matrix. Let's say max of op or op in mat, like this. This should be false. This should return me the A matrix. We'll return it from here. And this should be performed for all the rows. For row in mat, I will go over x in OP, row of x is 1, and append that in the A mat. Cool. Let's try to check this. This should be an integer. Wait, let's also convert this to an integer matrix. Index for x in mat, maybe. Three, 1, 3, 2, 2, 3. I'm wasting a lot of time in the parsing itself. I haven't even reached the solution yet. Int argument must be string, a bytes like object or a real number, not list. Okay. Should be row. I mean, this should be x for x in row. This should be for row in mat. Row of x is 1. List assignment index out of range. This should be +1 because we are using zero-based indexing. Invalid input for linear programming. Why is this invalid again? So now we have ops as 1, 2, 3, 4, 5, 6. 6 by 4. Now we have 6 by 4, and this part is, this should also be 4 by 1. This should be 6 by 1. Wait, why is this again wrong? So I have 6 equations, each six equation, 4 variables. But I don't have 6 variables. Why is this the case? Target array should be of size 4. Let's jot down this test case only. We got these equations. We only have 4 variables, so this should be something like, yeah, I mean, this should be transposed because the zeroth index, if you look at the test case, zeroth index is incremented by last and second last operation. So they should lie on the first row. So I think I just need to transpose this. Python transpose matrix. Let's use this. This should be used here. Let's try again. Now we got the answer, and optimal values for x are 1, 2, 4, 3. What did it give us? Minimum possible sum is 10, 12, and 11. I couldn't get what output is it printing. Okay, for each of the test cases. Right. So 10, 12, and 11 are correct, and I need to find out the sum of that. Where are we calling the function? This solution for line in lines. So this is part answer. Let's print this. Part answer is answer. Let's add this in the final answer. Final answer is what are we missing here? Let's also remove the debug statements. Unsupported type plus equals for int comma dictionary. Why is it giving me a dictionary? Okay, oh, this is the min sum. Let me grab this. And let's also keep the solution variable as it is. This is solution of yank inside this. Is it correct now? Part answer is this. They are using double variables floating point values, but we don't require it. I'm keeping it just to verify whether we get the same thing. Final answer is 32. Let's try it on the larger input. No such file. Is it into? Okay, it's fast enough, but I think we have. Why do we get a floating point answer? Sure. Let's remove this unnecessary logging. This should be 94, I think. Why is this a larger value? I'm not sure. This will definitely not be the right answer. 83. Let's ask ChatGPT whether can we assume integral answers and not floating point. What is changed? In modern SciPy, the integrality argument allows you to force x to be integers. Okay. np.ones and vars. Okay, let's try this. Integrality is integrality. Let's test again. Still we have some smaller values, I think. This should not be happening, but I think this looks good. I'll probably try this. Cool. So finally I got the right answer on this date and part 2. I mean, I'm literally treating this algorithm as a black box. So hopefully there is some better approach, optimized approach to solve linear system of equations. And this is how we have solved this question. Cool. There is one more article. I'm not sure if that gives the minimum thing, but the one we have used is linear programming from SciPy Python package. Okay, let's try once again just to verify. 18960. Cool. I'll have to also add in the dependencies for this. We have, I don't need a readme on this, this min.py, minrow.cpp, I can discard it, and PyProject and UV lock, I also don't need it. Stays this, and delete this. Commit solved day 10 part 2 in Python, specifically SciPy library. And let's push this. Let's move on to day 11. You hear some loud beeping coming from a hatch in the floor of the factory, so you decide to check it out. Inside, you find several large electrical conduits and a ladder. Climbing down the ladder, you discover the source of the beeping, a large toroidal reactor which powers the factory above. Some elves here are hurriedly running between the reactor and a nearby server rack, apparently trying to fix something. One of the elves notices you and rushes over. It's a good thing you're here. We just installed a new server rack, but we aren't having any luck getting the reactor to communicate with it. You glance around the room and see a tangle of cables and devices running from the server rack to the reactor. She rushes off, returning a moment later with a list of the devices and their outputs. Your puzzle input, for example, this. Each line gives the name of the device followed by a list of devices to which its output are attached. Looks like this is an adjacency list in some graph. BP has two outputs leading to this and this. The elves are pretty sure that the issue isn't due to any specific device, but rather the issue is triggered by data following some specific path through the devices. Data only ever flows from a device through its outputs. It can't flow backwards. So this is a directed edge from this node to its neighbors. After dividing up the work, elves would like you to focus on the devices starting with the one next to you. An elf hastily attaches a label which just says U, which is this case, and ending with the main output to the reactor, which is the device with the label out. To help the elves figure out which path is causing the issue, they need you to find every path from you to out. In this example, these are all the paths. Data could take the connection from this to this. Okay, so we just need to find out how many unique paths lead from one node to the other in a graph. I'm assuming this is a directed acyclic graph so that there are not infinite paths between any two nodes or the start source node and target node. Yeah, let's start with day 11. Use min.cpp. What else? The input format is like this. Let's also grab the input. This is the input. Let me print this just for reference. So string line, as long as we get the lines. So this should again be, this will ignore the spaces in this particular string. So we'll get the tokens AAA followed by colon and so on. So what I will do is, if line dot back is a colon, then I can say that this is the source node, string source, and what I need to do now is I need to assign source equals to this line, and I also need to pop back the last character. After this is done, to maintain the adjacency list, for now I'll probably use a map. Each node is a string, so the key is the string in the map, and it will have multiple neighbors. So it should be a vector of string as its neighbors. So if we receive this token, we update the source. Else, what we do is we simply add this particular neighbor. I'm creating unnecessary variables, but just to understand what is happening, I'll usually use it like this. This is neighbor. So once this is done, we will probably also have to let me go through this. So source would be updated here, and for all of this, the source would be AAA. All this would be added, and this will update the source, not add anything. Yeah, I mean, this should be good. Let's also print the adjacency list just to be sure. For auto kv in adjacency list, cout sources k and neighbors are for string. Oh, this is, let's say, neighbors. This is node u. Are you string v neighbors? I need to print v with spaces and add a new line at the end. Okay, let's go into that directory g++, back to r1 main on in1. Let's try this. Cool, looks correct. This last line input is also correct, so let's move ahead. I'll comment this for now. Now what we need to do is we need to find the starting point and how many nodes, how many paths are there. So I'll simply use a DFS starting from u. And what else do we require? I'll use a top-down recursive solution for this. Answer is this, cout answer. Let's write int dfs, or let's call this go, because I'll be memoizing values in this and not just doing a dfs. So const string current node, if node is, what was the target node, out, then we have reached one path, we have traversed one path which gives us the answer. And if that is not the case, let's say this is ways, go over, let's extract out the vector first, const auto neighbors as adjacency list of this node, go over all the neighbors. Let's say this is v in neighbors, and ways plus equals to go of v. I think this should be the basic thing that we need to do. Let's see if we need to optimize this or not. Answer is 5, looks correct, but this won't probably work for the larger test case because there are huge number of nodes in this graph. Before that, I'll optimize this. To optimize, I will use memoization, and to do that, for now I'm not thinking about constant optimization of converting the strings to integers, because that is not necessary. The input is not that quite large. So let's use a string of int dp array. If this particular state is computed, so dp dot count node, then we need to return dp of node, else we need to update dp of node as the ways that are computed. Let's try it on sample test case first. Answer is 5. Let's try it on the larger one, 466. Let's try this. Cool, we got the answer correct. I'll probably also push this code, sample input, sample mean input. We don't need the binary. Let's delete this, and this is the code for part 1. Commit this. Solved day. Which day is this? 11. Day 11, part 1 in C++. Code is pushed. Let me add the link to Advent of Code 2025 in chat. Cool. Let's see what they're asking for part 2. Thanks in part to your analysis, the elves have figured out a little bit about the issue. They now know that the problematic data path passes through both DAC, a digital to analog converter, and FFT, a device which performs fast Fourier transform. They are still not sure which specific path is the problem, and so they now need you to find every path from SVR to out. However, the paths you find must also visit both DAC and FFT in area order. Doesn't look difficult. Cool. I think this will only require a very small optimization to part 1. I have got the idea of what is asked. So let's copy main1 to main2, edit main2. We need to start from SVR. So this should be updated. SVR And one more thing that we need to take care is whether those are visited or not, DAC and FFT. So they should be Boolean DAC visited, Boolean FFT visited. Let's also create constants for this. Const string DAC as DAC and FFT as FFT. And this should only happen when DAC is visited and FFT is visited. Only then we are considering that this is one valid way, and any order is fine. To update this, before moving on to the next state, I need to make sure that DAC is already visited or DAC is this particular node, and the same thing for FFT. FFT is this particular node. Cool. Next thing that I wanted to do is use this Boolean variables as suffixes, indices for this particular state in the dynamic programming. DAC visited, FT visited. This should be off node, and also update this. Let's copy this. Ways. I think this should be it. Let's try the sample case. And this to do is also complete. Let's remove this. Am I missing anything? And all the paths that lead from SVR to out. Okay, out is correct. And how many of those paths visit both DAC and FFT? Looks good. G++ main2 on in1. The answer is 2 for this. We got 0. Why is that the case? /main or in1. So this is stack. Initially, both of them would not be visited. So both of them are false. And this condition is also correct. Equals p DSE DAC and 50 is also correct. So why is this failing? Let's remove the memoization for now. The answer is still 0. Have they given some other test case now? I think so. Yeah, let's try this. Let's say this is in3. /main on in3. Answer is 2. Looks good. Now let me run this on. But now this won't work without memoization. I mean, it would be slow. So let's revert back. Or if I haven't changed anything, this answer that we got earlier should work. We'll try submitting this. That's the right answer. Cool. I can post this on Twitter. Let's try this once again. main2 on in1. In 1 is fine. I need to test it on in 3 and in 2. This is the answer. Cool. Let's check on the answer page. I'll also post a stream for Advent of Code 2025. Where can I get the shareable link for this? Okay. Five four nine seven. Let's verify this once again. Cool. We got this answer. So today I solved 3 problems. Day 10 part 2, day 11 part 1 and 2. 11 was slightly easy, 10 was a little bit trickier. 9 part 2 looks much more difficult to me. I haven't thought much about it, so probably get back to it later. And 12 is probably a little more difficult than this again. I'll get back to this after thinking about a solution instead of wasting a lot of time doing live stream. Cool. Thanks for watching. See you guys later.